Hello everybody. In this video, I will briefly discuss basic definitions and terminology of differential equations topic. I will give you some simple examples of what differential equations look like, and we'll solve a couple of problems where we verify general solutions. So let's go ahead and take a look at some simple equations that we've solved in other classes, such as algebra. Let's say we have a linear equation in one variable, 2x plus 10 is equal to 16. We all know how to solve this equation. So this is 2x is equal to 6, x is equal to 3. We have a solution to this equation. It's a number and it's unique, meaning there's no other number will make this equation true. One and only one. Okay, so that's our first example. Let's take a look at the second example. Says something like this: x squared minus 1 is equal to 15. This is a nonlinear equation in one variable. Okay, we know how to solve this one. This is x squared is equal to 16, so x is equal to plus or minus 4. Okay, so in this case we have two distinct numbers that make this equation true. Okay, so in the first example we had one number was unique. In the second example we have two numbers and they're different, but we still have a finite number of solutions. Okay, let's take a look at the next example. This one says x plus 7y is equal to 20. Okay, so this equation has many solutions. You might be saying, well, how many? Infinitely many, right? Give me a value for x or y, and I'll tell you what the corresponding value of the other variable is. Okay? In fact, what is this object that describes all solutions? Well, it's a line. Okay? It's a line in a plane. Okay? One particular solution could be, let's say 6, 2. Okay, so solutions in this case are ordered pairs. Okay, and there are infinitely many of them. So when solving an equation, you can get all sorts of scenarios depending on what type of equation you're dealing with, right? You can get one number unique, you can get two distinct numbers, or you can get ordered pairs, and there's infinitely many of them, and that's of course not exhaustive. There's many other things that can happen. So these are equations that we know how to solve and now we know how to deal, but notice that the solutions to equations are in this case are numbers or ordered pairs. Okay, now what about differential equations? So in differential equations, a big difference here. The solutions are not numbers. Okay, solutions are functions. Functions, okay? Whole families of functions sometimes. Okay, so not numbers, and this is number one thing that I want you to get out of this introductory video. The solutions to differential equations are not numbers, they're functions. Okay, I'll emphasize it again. Functions. Whole families of functions, different functions. Could be a lots of different things. Exponential, logarithmic, trig, polynomials. You'll see all sorts of examples, okay? So we're dealing with relationships of functions and their rates of change. So, things like first derivative, second derivative, and so forth. Okay, so differential equations are what? Okay, differential equations where we have a relation between the function, usually unknown, so let's say y of x, and its derivatives is given. Okay, so I'll give you your first example. Okay, something like this: y double prime minus, nope, just kidding, plus 16y is equal to 0. Okay, what does it say? It basically says I have some function such that if I take the second derivative of that function and add it to the constant multiple 16 of that function, then they add up to 0. Okay, so one particular solution to this equation is y is equal to cosine of 4x. Okay, so far we're not learning how to solve these yet. Okay, I'm just telling you. So it is known that this is a solution. Okay, let's just go ahead and check it. Okay, so y prime is negative 4 sine of 4x, and then y double prime is negative 16 cosine of 4x. Okay, so now if I do y double prime plus 16y, what do I get? Well, double prime is negative 16 cosine 4x plus 16 of what? Y, but y was cosine of 4x. Okay, yeah, that is 0. So I just verified that this is a solution. Okay, we verified this. So the idea is you have some sort of relation between the y, the unknown function, and its derivatives. Okay, and we need to find the function or whole family of function that satisfies this equation. Okay, so let's talk about a couple of terms when it comes to differential equation. So first thing that we need to discuss is the order. Okay, order of differential equation is the highest order of the derivative. Highest order of the derivative in the actual equation. Okay, so for example, if you have y double prime plus 16y is equal to 0, this equation is second order. Second order because of what? Because of this piece right here. Okay, let's say you have something like this: dy dx minus 4y is equal to 10x, something like this. Okay, this is first order. Okay, y. This is the first derivative of y. And this is the section where all sorts of notations will be used. So sometimes you'll see dy dx, other times you'll see y prime or y double prime. So we need to be careful and be comfortable with using all of these notations. Okay, we could have something that looks like this. Let's say y prime of t is equal to 0.10 y times 100 minus y. Okay, this is also first order. How so? Okay, first derivative is the highest derivative here, right? Okay, so this is the first term that we need to keep in mind, determining the order of the differential equation that's given to you. Okay. Then the next terminology that I would like to discuss is linear differential equations. I'm going to abbreviate differential equations as DE. So let me put it right here. Differential equations. Okay. So linear differential equation. What does that mean? Okay. In the differential equation, y and its derivatives appear in the first power not composed with any other powers, and no product or quotient of y and its derivatives. Okay, not composed with other powers. Okay, and no quotients or products of y and its derivatives. Okay, so this will take us some practice to determine. So let's see. This first equation, y double prime plus 16y is equal to 0, it is linear. All derivatives are in first power. Okay, there are no quotients, there are no products, no composition with other powers. Okay, let's see, what about the second one? dy dx minus 4y is equal to 10x. This is also linear. Okay, now the last one is nonlinear. Nonlinear, okay, because this will give us y squared, right? Okay, once you multiply this through, you're going to get a power of the function itself. Okay, so this is nonlinear. All right, so now what I would like to do, our first objective in this set of lectures. Okay, verify the general solution. Okay, verify general solutions. So we'll have a few examples to go through. So let's take a look at example 1. Okay, this one says I have the following equation: t times y prime of t minus 3y of t is equal to 0. Okay, and the solution that they give us is y of t is equal to c, which stands for constant. Okay, t cubed. Okay, we're verifying. We're not solving this. Okay, not solving this problem. We don't know how to solve differential equations just yet. Okay, we just need to verify that this is indeed a solution. Okay, so what is y prime of t? Y prime of t is 3c times t to the second power. So now here's my verification. If I do t times 3ct squared minus 3 times y, which is ct cubed, is that equal to 0? Well, let's see. This is 3ct cubed minus 3ct cubed. That is equal to 0. Okay, we just verified this. The solution to this first, what is this? First order linear, right? Okay, so let's take a look at the second example. Okay, second example says y double prime x minus y of x is equal to 0. This basically says what? The second derivative of the function is the same as the function itself. Okay, they give us the function to verify. Y of x is equal to c1 e to the negative x plus c2 e to the x. Okay, so the c1 and c2 could be any constants, right? So let's verify it. What is the first derivative? The first derivative is negative c1 e to the negative x plus c2 e to the x. And then the second derivative would be what? Minus and minus give us a plus. And then c2 e to the x, which is exactly the same as y of x. This is y of x. So yes, that's it. That's all we need to verify. Okay. All right. So then the last example for this video. Let's say we have the following: y double prime of t, u double prime of t, minus 2u prime of t plus u of t is equal to 0. Okay, so they say the following: take the second derivative of a function, subtract 2 first derivatives, and add the function itself, you're going to get a 0. Okay, so what is the function u that satisfies this? Okay, let's see. Just to review our terminology, this is second order, right? Linear. Okay, second order linear differential equation. Okay, they give us a general solution. So they say y of t, not y, sorry, u, is c1 e to the t plus c2t times e to the t. So let's verify it, which means we need to find the second derivative and the first one. Well, the first one first. U prime is what? C1 e to the t plus, product rule here, C2 e to the t plus C2t e to the t. Okay? Then U double prime, C1 e to the t plus C2 e to the t plus product rule again. So that's C2 e to the t and plus C2t e to the t. Okay? Now, well, we can combine two terms here, right? So this is 2c2 e to the t plus c2t e to the t. Okay, lots of t's. All right, let's plug this in. So the second derivative first. So that's c1 e to the t plus 2c2 e to the t plus c2t e to the t. Okay, and that is our second derivative. Minus 2 of the first derivative. So that's c1 e to the t plus c2 e to the t plus c2t e to the t. Okay, so this is u prime and plus the function itself. So c1 e to the t plus c2t e to the t. Okay, what is this equal to? That's the question mark. All right, let's see if we can collect like terms. First, I'm going to deal with all c1 e to the t. Okay, so here's one positive, and then this one will give us 2 negative, so that's gone, right? Cross this over. Okay, now I'm going to deal with 2c2 e to the t. Okay, so 2 of these are positives, okay, and this 2 will distribute here as a negative, so that's also gone. Okay, all right, what else we got? c2t e to the t, 1, 2, and then there's 2 negatives over here. Okay, so that's also gone. Everything cancels out, so the answer is 0. All right, so this function is a solution to this differential equation. Okay, all right, we'll stop right here. In the next video, we will discuss specific types of differential equations and how to solve them. Thank you for